video, we are going to find out energy and power or energy repeat. In this video, we are going to find out energy or power of a signal, and from that we will check whether the given signal is an energy signal or power signal. And we are doing this exercise for continuous time signal. So let's take an example where continuous time signal is a standard step response. So S of t is u of t. For this, we need to find out what is the energy and or power. So first we will plot this. It's a standard step, and the plot will be like this. So it is having the value 1, which we call as the magnitude, and that exists from 0 to infinity. So for this signal, the energy is given by integral minus infinity to infinity x square t dt. It is a standard formula. Being a unit step signal which exists only from 0 to infinity, I'll change the limit 0 to infinity and the magnitude is 1. So it is 1 square d. Now 1 is a constant, so that will come out, no need to show. Inside integral we have dt, whose integration is t, and to this we are applying the limit. So the upper limit is infinity and lower limit is 0. So it is infinity minus 0. And as we know, whenever infinity comes in the calculation, it always gives you a final answer as infinity. So signal energy is not finite. So pertaining to this, I can say given signal is not energy signal. Whenever we decide the given signal is not an energy signal, that does not mean the signal will be power signal. We need to prove that power should be finite in order to say the signal is a power signal. For that purpose, let's find out its power. The power of any signal is given as P infinity equals limit t tend to infinity 1 upon 2t minus t to t x square t dt. So this is the formula for power of any signal. Once again, being a unit step signal, this exists only from 0. So this can be changed like this. Limit will be 0 to t because the signal is a unit step having the value 1. If we solve this, we will get 1 upon 2t, inside bracket there is a dt whose integral is t, the limits are 0 to t. So we will get answer by applying the limit, which is nothing but t Now, I can cancel this value of t, but we need to write something related to the limit, and that something is like this. Since t tending to infinity, what is the meaning of this? T tending to infinity. T tending to infinity means t not equal to infinity. So, as we know, a thumb rule of maths, you cannot cancel out infinity from numerator and denominator, because if infinity is not defined, operation based on infinity cannot withstand. So for that purpose, over here I am writing t tending to infinity means t not equal to infinity. That implies t will have some finite number, and finite number can be cancelled out. So after doing this, I will get a p infinity equal to 1 by 2, which is a finite number. So I can say, since power is a finite number, what I can say, given signal is a power signal. So here we have applied the concepts of energy and power of a signal to a continuous time signal, where a simple standard unit step function was given. Thank you.